let's do this problem here. What we are given is the function of f and the function of g, and this restriction here which shows that the graphs are drawn within this range. And we're given the graphs, and the first question says we should determine the values of m and n. So to determine the value of m, we have the function of f, which is equals to cos of x plus m. This m is your y-intercept of f, right? So looking at this is the function of f, so there is the y-intercept. The y-intercept is this here, which is 0.5. So meaning that m is actually 0.5, which you can just say it's 1 over 2. Fine. And then now we are going to go to the function of g, which is sine into x plus n, right? So we want to find this n here, which is a shift. It's a horizontal shift, right? So we're just going to look at our function of g, and our function of g normally starts at 0 because it's a sine function. But in this case, this one, it's somewhere here, which here, the angle, it's negative 30 degrees, right? So which means this graph shifted 30 degrees to the left. So the shift is 30 degrees to the left, right? So meaning my n value is equals to 30 degrees. Fine. And then the second question says that we should find the amplitude of f. So remember, this is f. So what you will do is you're going to look at the highest point of f and the lowest point of f. So this is the highest point of f, which is 0.5. So amplitude is equals to, the highest point is 0.5. What is the lowest point of f? It's this one here, which is minus 1.5. Obviously, when you find the amplitude, we don't care much about the signs, so we're just going to take it as positive. So it's just going to be plus 1.5. And then you divide by 2. The answer here is going to be 1. So this is going to be your amplitude. Fine. And then we go to this question here. 8.3 says, if h of x is equals to g into 2x, like this, write down the period of h. So we know very well that our g of x is equal to sine of x plus n, right? And we found that n is equal to 30, so it's going to be sine into x plus 30 degrees, right? And then now they're saying function of h is equal to g of 2 of x. So meaning our function of h is going to be sine, open bracket, 2, open another bracket, x plus 30 degrees, like this, and then close bracket. So this is how it's going to look like, right? So when a function is like this, what is normally affected is the period. This 2 affects the period, right? It's almost like you're saying 2 and then the entire thing if you say x, right? It's just more like that. But so these 2 will affect the period, so meaning it will half the period, right? So normally the period of a sine function is 360 degrees, right? So but because we have we're going to have sine of 2x, which means you're going to have 360 degrees divided by 2, which is equals to 180 degrees. So this is going to be the period of the graph of h, which is 180 degrees. And then we come here in 8.4, it says, for which values of x will the function of f multiplied by the function of g give you negative solutions of y, right? So when you multiply the y values, both y values, they must give you negative solutions. Let's go to the function and say, for example, let me do this. So here the y values are positive, they're positive, they're positive. Here they are negative, 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 negative. Even here they are negative, 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 and then here y values are positive, right? So you want a situation where Remember, we were given the restriction. It said we must look at 0 to 240 degrees. So from here to here. So if we were to take this portion, just this portion, we won't get negative solutions of y because we only have positive solutions of y. If a positive multiplied by the positive is going to give you a positive. So we don't want this. We want a situation where we're going to get a negative solution of y. So where is that? If we have a look at this region from here, right? From here all the way up to here. So if we multiply this positive solution of y with this negative solution of y, we're going to get negative solutions, right? So this is the range that we're looking at. So this range starts at 60 degrees up to 150 degrees, because remember that the difference is 30 degrees, right? So the range lies between x lies between 150 degrees and 60 degrees. So this is going to be your answer for this question here. I'm going to go to 8.5, which says describe the transformation that the graph of G undergo to form the graph of P. This is the graph of P. So the graph of P is equals to minus cos of x. What is the graph of G? Let's identify the graph of G. The graph of G is equals to sine of x plus 30 degrees. So we want a situation where this graph of G changes into this one. So we want to describe the transformation. What should happen? So here's how we can do this. So if we want to determine the graph of P of x, right? It's going to be equals to the graph of G of x, which is equal to sine of x plus 30 degrees, right? So for us to experience a shift that will, or a transformation rather, that will give us this equation is if we add 60 degrees here. So if we add 60 degrees here, we're going to get sine of x plus 90 degrees, right? Of which is going to be sine of 90 degrees plus x. So if we reduce this, remember that sine in the second quadrant, if we do this cast diagram, is positive. So we're going to write cos of x, right? So we've achieved this small part, but now we want to achieve this negative. How can we get this negative? So the one way to get this negative is if we reflect the function about the x-axis. So when you reflect a function about the x-axis, the y values become negative. Or should I say the y function becomes negative. So you have the function of P of x equals to cos of x, right? So if we're going to shift the function of G about the x-axis, we need to make it negative, right? So meaning that our P of x now is going to be negative cos of x like this.